Hello and welcome to this special edition of Space Talk with the American Astronautical Society. I am Dr. Amir Gohardani, the host of Space Talk and the editor-in-chief of Space Times. If you follow our regular programming, you might know that we dissect space-related topics through the expert investigations of our guests. If you happen to be new to the program, welcome on board the spaceship. In the special editions of Space Talk, we break away from our regular programming sequence by asking thought-provoking questions to our invited guests. And this time, nothing is different. Welcome on board.
Before revealing today's special guest, let us reflect upon these words. Science distinguishes itself from all other branches of human pursuit by its power to probe and understand the behavior of nature on a level that allows us to predict with accuracy, if not control, the outcomes of events in the natural world. Scientific discovery often carries the power to broaden and deepen perspectives on all things. Science especially enhances our health, wealth, and security, which are greater today for more people on Earth than at any other time in human history. These words are an extract of the book Starry Messenger by today's guest, Dr. Neil deGrasse Tyson. Now that our guest is revealed, let's learn more about him. Dr. Tyson is an astrophysicist and the author of the #1 best-selling Astrophysics for People in a Hurry, among other books. He's the director of the Hayden Planetarium at the American Museum of Natural History, where he has served since 1996. He's the two-time host of the beloved TV series Cosmos, rebooting the original 1980 series hosted by Carl Sagan. Dr. Tyson is also the host and co-founder of the Emmy-nominated popular podcast Star Talk and its spin-off Star Talk Sports Edition, which combines science, humor, and pop culture. He's a recipient of 21 honorary doctorates, the Public Welfare Medal from the National Academy of Sciences, and the Distinguished Public Service Medal from NASA. Asteroid 13123 Tyson is named in his honor. Dr. Tyson earned his undergraduate degree from Harvard University and his graduate degrees from the University of Texas at Austin and Columbia University. Hello, Dr. Tyson, and welcome to Space Talk.
Oh, thanks for having me. Please call me Neil.
Okay, Neil, thank you. It's really a pleasure for us to have you here, and there are so many questions I like to ask you, so we probably won't have time to go through all of them, but we do our very best. First and foremost, I'd like to congratulate you on your new book, Starry Messenger. I just finished reading it. Fascinating read. And what stood out to me was that you covered so many topics between heaven and earth, literally.
Yeah.
and it's just amazing. So, well, there are many questions regarding the book. Maybe the most prominent that I thought would be most appropriate for this talk would be, why did you call the book Starry Messenger?
The book is a in a way, it's a compilation of my life's observations of how science can shape what the world looks like to you. The world includes civilization, people, places, things. And I reached an age, because I'm an old man now, where it's like, okay, it's time to put all this in a book. And I couldn't have written it even 10 years ago, I don't think, maybe not even 5 years ago. Because ideally, as you get older, you become wiser. Otherwise, what's the point of getting old? Is it just
That's
to become crickety? Is it just to become, cranky? And so there's no, these were my goals as I got older, that I would be able to invoke some bit of wisdom accumulated over all the years. And so beyond that, what I noticed is Galileo in his early days when for his first book, he was the first to, I don't know if he was the first, but the first to write about taking a telescope and looking up with it. All right. He had heard about a telescope that was developed in the Netherlands and where they combined two lenses. And he says, well, that's brilliant. I'm going to make my own version of it. And he made a very good version of it. By the way, no one at the time called it a telescope. It was called a spyglass. Okay. Which is evidence for what people were doing with it at the time. He may have actually been the first person to look up with it, all right, rather than in other people's windows. So he compiled his observations of the heavens, which were extraordinary. He looked at Jupiter and noticed that Jupiter had objects orbiting it. What? Earth is not the center of all motion? Can this really be true? This is an astonishing revelation brought to you by the methods and tools of science. He noticed that the planet Venus goes through phases. What's up with that? He noticed that the surface of the moon had texture, mountains, valleys, craters, hills. He noticed that the sun had spots. Today, we still call them sunspots. Yes. So that was just a little weird. So this perfect heavenly dome above us had these imperfections. It had this weirdness going on. It conflicted with what we were told was true about the universe and what we wanted to be true about the universe, that we were somehow in the center of it all. And that was a privileged place. All right. If you're not in the center, then why should you be anywhere else but the center? And we can argue about whether the center is a good place or a bad place to be, but it's nonetheless a unique place to be in the then known universe. He viewed these discoveries as messages from the stars and titled his first book Sidereus Nuncius. In Latin, you get Starry Messenger. And so I thought to myself, here I am in that tradition, invoking the methods and tools of science, applying them to the world around us, getting wisdom drawn from what we have learned astrophysically from the heavens, and applying it to so many of the pivot points in our culture and in our society that has caused conflict without resolution. And so this, for me, is a modern attempt to have the universe bring us messages that will not only rectify, but I think also improve our understanding of our relationship with each other and our relationship with the universe.
That's really fascinating. And you touch upon, Galileo's discoveries that are obviously, part of, I would say, scientific history is really pronounced portion of it. And in your second chapter, you call that exploration and discovery. And this is very appropriate. And to me, this topic is really one of the most fascinating things about the universe. I was reading the other day an article where astronomers at a university in the United Kingdom actually found this massive black hole. I would call it ultra massive black hole because the size of it and the
mass is 30 billion times our sun. And so having a context like that, what does exploration, in your opinion, mean to mankind? How will it evolve?
So I don't think at any given moment you can know for sure what the exploration and discovery in that moment, how that will matter in later times. Often discoveries are, they're just curiosities. And then later on, other people get to think about the discovery, especially engineers and other sort of clever people that like solving problems that we confront in civilization. And then you find that discoveries manifest in other ways as it trickles down from the bleeding edge of scientific discovery to everyday life. And I'll give two examples. One, we are now in the centennial decade of the discovery of the major tenets of quantum physics. So the 1920s were when most of what we today think of as quantum physics was developed. The wave-particle duality, this sort of thing. And although the quanta itself was revealed, I should say, in 1900, we didn't develop a branch of physics around it until 100 years ago in the 1920s. So you take quantum physics and I say, well, you're really smart. I need you to solve our societal problems. Why are you wasting it thinking about atoms and how atoms behave and particles? You can't even see them. I'm a carpenter. I just care about my wood atoms. I don't need to know anything deeper than that. And you're wasting government money as a scientist or grant money or whatever. So you could imagine people criticizing some of the most brilliant minds of the day engaging in this activity. Fast forward 40, 50, 60 years, 50 years to be a little more precise. And what do we find? Quantum physics is foundational to the rise of information technology. There is no creation, storage, and retrieval of information, of digital information, without exploiting our knowledge of the quantum. And so that was many decades delayed in how those discoveries would affect us here on Earth and in society. So my reply to you is, the urge is strong to say, how will what you're doing today affect me today? And I'm saying, I don't know. Maybe never, or maybe significantly. But what I do know is we are living better, more healthily, longer, with less disease, and overall happier as a civilization than at any previous time. And practically all of that is brought to you from the applications of the discoveries made invoking the methods and tools of science. So the discovery of a black hole, I don't know. But if it means someone says, I have an idea for a movie, and I'm going to make a movie, and I'm going to hire 1,000 people. All right. Have you see the credits? You ever stay for the credits of blockbuster movies? The names just keep going. All right. Here's an idea. All right. Maybe it's not the science that we're using, but it's the idea that's fun and it's storytelling. We like being entertained.
Right.
If it is as a minimum that it's good, why not? Let's do it.
Intersection of science and sci-fi and of course society has always been there, inspired actually many engineering outcomes later. So
Yes.
It's a very fair point. You talk about basically quantum physics, and when you talk to people who are new to the space arena and you say this quantum physics, sometimes it invokes this, I don't really know what you're talking about. Can you explain quantum physics in a more layman terms? Or
no. No. Yeah, so I forgot who said this. Was it Max Planck? One of the early physicists who were engaged in the discoveries of quantum physics said, back then known as quantum mechanics, they said, if anyone ever tells you they fully understand quantum physics, then how's it go? That they actually don't, because you can't understand. It's not, quantum physics is not something to be understood. It's something to grow accustomed to. You learn that something can be a particle or a wave, some combination of what? What does that mean? What is going on? You know, what? Two protons want to repel each other, as we know, because they have the same charge. But if you get them close enough together, they'll attract? Like, what? And they'll only attract if you have neutrons mixed with them? What? Why? How? What? Who? And you have an energy field, and then particles can pop into existence out of that energy field? What? Why? How? And the particles have equal and opposite properties, going in opposite. So these are discoveries about the universe on its smallest scales that survive experiment, peer-reviewed experiment, that are duplicatable every single time. And they don't make sense in any classical way.
Right.
So I've said many times, the universe is under no obligation to make sense to you. All that matters in the end is if what is true about the universe, what we say is true about the universe, is supported by repeated experiments and observations. If that's the case, then that's the universe. Deal with it.
Right. And that goes back to the discovery, right? So it has quantum physics has allowed us to do so many more discoveries to try to expand our knowledge, or rather limited knowledge in this arena.
I'll make a stronger statement than even that. Of all the branches of physics, quantum physics is far and away the most successful among them. Like, I don't know any prediction of quantum physics that has not yet come true. That's been tested, and whereas other things that are also very successful, like general relativity of Einstein, you realize at the center of a black hole, you're dividing by zero in the equations, essentially. And so what happens? It blows up with infinite density. Really? So many suspect, and I agree with this, that the limit of general relativity is at the point where it says you have a singularity. Yes. And maybe something else needs to be invoked. So we're looking at the boundaries of how general relativity can apply to the known universe. We have yet to find boundaries to quantum physics.
And
like I said, deal with it.
Yeah, just deal with it, right? And that brings me to another interesting terminology, I would say, that was repeatedly read by me in your book, and that's cosmic perspectives. Can you tell us a little bit about cosmic perspective and how do you perceive that?
Yeah, well, the entire book is about cosmic perspectives because it's cosmic perspectives on civilization. And it's a view that is, we hear about the overview effect where astronauts go into orbit and they're up above and Earth is below, and it changes you. Always for the better, I think. Right. It gives you a deeper sense of our place on Earth and in the cosmos. But I claim there's an even higher perspective than that. And that's one. Oh, by the way, how high above Earth are they? You ask random people, they'll give you the wrong answer. You say, here's a schoolroom globe. How far from the schoolroom globe are the astronauts? And they might say 6 inches, a foot, whatever, right. In metric, 10 centimeters, 20 centimeters. And no. The International Space Station is orbiting 1 centimeter above Earth's surface of a schoolroom globe. Yeah. So for me, as an astrophysicist, that's not space.
No.
So you want to go into space with the astronaut? I say, no. If you're going to send me to space, give me a destination. The moon, Mars, beyond. I don't need to boldly go where hundreds have gone before in low Earth orbit. Right. Point is, The point. Where was I? The whole point of this, I was describing
Cosmic perspective.
Oh, cosmic perspective. So if you go farther away, like to the moon, then you see the entire Earth. You don't see the entire Earth from 1 centimeter above a schoolroom globe, but from the moon, there's Earth alone, adrift in darkness, with oceans and land, clouds, and you realize, oh my gosh, when we all grew up, in the back of the shelf in the schoolroom, there was a globe of Earth with color-coded countries. And I'm thinking, well, why did they do that? Oh, so you can have geography as, okay. But I got cynical as I got older, and I said, they were telling us who our enemies were and who our friends were.
Right.
There's a line in the sand. Don't cross that line. Or if you do, you have to carry special permission. And I'm thinking, really? This is one planet with this land masses, aliens coming upon Earth. That's what they would see. They would see oceans and land, and they say, oh, let's go meet the humans. Okay, let's see how they must enjoy life on Earth. And they go down and find out that we've divided ourselves by how reflective your skin is to sunlight, by who you worship, who you sleep with, where you live, where you were born, where you travel to. And we've taken up arms against one another on that premise. And they say, but wait a minute, isn't there just one planet and you're one species? And isn't it one? And then they would immediately return home and tell their fellow aliens there's no sign of intelligent life on Earth.
Right.
Their perspective is a cosmic perspective, and I think there's not enough of it.
And I love, and I'm going to piggyback on what you just said about observing the blue marble from the moon. And you actually have a quote in your book that says, "Our goal was to explore the moon, but while doing so, we look back over our shoulders and discover Earth for the first time." And that really hit home with me because, I've stared at that globe in the geography class, and basically that reflection about, wiping off all the borders and coming together as one man, humankind. It's something that, as you very elaborately touch upon in your book, something we struggle with. And maybe these cosmic perspectives can allow us to think beyond those borders and those shades and colors and actually walk into that territory where we get a maybe more grandiose view of what this universe is all about.
Well, thank you for noticing, for picking out that quote, because we on Earth changed after we saw Earth that way. The modern environmental movement traces exactly to the publication of that first photo from Apollo 8 in 1968, where you see Earthrise over the lunar landscape. And my opening quote from Edgar Mitchell, the Apollo 14 astronaut. I'll recite that quote here, and then no one has to get the book because that quote is the entire book. Okay? You can just, okay, I know where he's coming from. So if I remember the quote, it goes, again, this is an Apollo astronaut coming back to Earth, and he's interviewed, I think it was in Time magazine, and here's the quote. "You develop an instant global consciousness, a people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. From out there on the moon, international politics looks so petty. You want to grab a politician by the scruff of the neck and drag him 250,000 miles out and say, 'Look at that, you son of a..." Okay. Now that's the book right there. We got
That's a summary.
Okay.
Wonderful. So I want to hear your thoughts, Neil, on two schools of thought. One is, and this is very, very, I would say, I wouldn't say popular, but something that I've witnessed being part of the space industry, that this first school of thought is let's do more space exploration. Let's do more discoveries. Let's concentrate in, our efforts to get to space easier, almost many times a day versus several, months or years in the past with one launch. So that's one school of thought with increased space activities and this hunger for exploration, whether it's robotic or human. The second school of thought is let's abandon all of that and concentrate on the challenges we face on Earth. And that would be hunger, vaccination, anything that can benefit other human beings on Earth. What is your take on, I wouldn't ask you to say which one is correct, but what is your take on maybe fallacies within these schools of thoughts?
So a couple of things. First, by the way, the book offers perspectives. It's if you have an opinion, a strongly held opinion, the book says, well, have you thought of it this way? Have you considered this bit of information that might influence? Because I don't really care what opinion you have, as long as it's fully formed, right? Yes. And fully explored with all of its nuances, and then land at your opinion. But if your opinion is malformed or partially formed, then that's not an opinion. That's just you're just being grumpy. Okay. Get off my lawn. Why? I don't know. Just get off my lawn. That's just so my response to that is very simple. And I go back to the days when we were living in caves. And so let's say we're a cave tribe. There we are. And the young ones in the cave, they peeked out the cave door. They left the cave door ajar overnight. I don't know if caves have doors. Probably hinges weren't invented yet. Let's imagine it's a hinged cave door, right? And so it opens up, and the kids look outside, and they see mountains and trees and fruit. They wouldn't have a word for fruit because no one's ever been out there yet, or that far. And they see rivers, and so they go back to the cave elders, and they say, we want to explore outside of the cave. And the cave elders gather, because they're wise and they're old, and they say, and they come back and they say, no, we cannot permit that. Well, why? Because we have cave problems that we need to solve first. Okay. Only after we solve the cave problems will we have the luxury for you to go out and explore.
Right.
Okay. That's what you sound like to me. If you're going to say we have problems on Earth, we should not spend them in space. We should not spend money in space. That's my first pass at that exchange. My second pass at that exchange is, why are you so sure that solutions to Earth's problems cannot be found in space? From techniques, methods, tools, engineering. Also, maybe I have a brilliant engineer who's not interested in solving the hunger problem, but is interested in getting astronauts to Mars. In a free country, that engineer should be able to choose that as a career. Now we tell the engineer, oh, by the way, we got to feed the astronauts for 9 months, and they have to somehow support themselves on Mars. And then they invent a new kind of crop, a new kind of food that lasts 9 months, that can reproduce itself in that, and then this would then transform the entire farming industry.
Yes.
That is not so out of reach for me to think about. And you know something? They'll be much more inventive doing what they want to do, doing what they love doing, than someone saying, no, you cannot do that. Come here and figure out how to feed this person who's hungry. In a free country, when you allow people to explore what they love, they will reach heights never before imagined by anybody else doing anything else. And that's where such discoveries can benefit us. Take, for example, I had a professor in college a physics professor who was very much interested in molecules in space. Okay. And in how they interact with radio waves and other kinds of electromagnetic energy. Oh my gosh. He and some colleagues discovered a new phenomenon called magnetic resonance, where the nucleus of an atom, when subjected to a magnetic field, can influence what light does as it passes by. They got the Nobel Prize for this. It was called nuclear magnetic resonance. A clever engineer looks at that and says, hey, I can take that principle, apply it to a machine, and put you in the machine, and I can make images of the atoms in your body with way more detail than a simple X-ray can do.
Yes.
Plus, X-rays doesn't resolve soft tissue, only your bones, basically. All right. Whereas this machine can tell you where slightly different atoms are that are collecting in your body. Thus was the invention of the magnetic resonance imager. Okay.
Very interesting.
Okay. So the MRI, the MRI, which in its full name is nuclear magnetic resonance imager. It uses NMR. Okay. But people, nuclear is one of the two N words you're not supposed to use in polite company. So the medical world dropped the N, but it is nuclear. They dropped the N, and it's the MRI, the magnetic resonance imaging, using nuclear magnetic resonance, discovered by a physicist who had no interest in medicine. A physicist that's a interested in the universe with no interest in medicine.
It's just a perfect
no one on Earth would have done that.
No.
You can't say medical doctors invent nuclear magnetic resonance. That's not going to happen. It's not their background. It's not their training. They can't even know how to think that way. So I say to you that if you require that all the brilliant minds in the world only work on the problems you want them to solve and not the problems that excite them the most, that will be a regressive force in the progress of civilization, based on the history of this exercise.
And it will definitely create resentment to the one asking. All right. This is really interesting, Neil. So how about we jump into space sustainability? It's a very, I would say, call it a buzzwords. People use it in all kinds of contexts. And how do you perceive space sustainability and its evolution over time? And I know that's a very broad question, but just your initial take on it.
Well, I think we have a lot of other sustainability issues that confront us right now, such as energy sustainability and pulling fossil fuels out of the ground that represent a finite total supply is not a sustainable way to keep us going for the unlimited future. There may be some insights to glean by sustaining colonies in space, all right, population centers either on the moon or on Mars. It's not realistic to think of other destinations to put colonies unless you put colonies in free-floating space.
Yes.
You can imagine space stations at one of the Lagrange points in the Earth-Moon or the Earth-Sun system. These are the points in an orbiting pair of objects where all the forces of motion and gravity and all the accelerations balance out. And so that it takes minimum energy to sustain that location in space. And so they're called Lagrange points, discovered by the French mathematician Lagrange. I forgot his first name. Would you remember his first name? There's Lagrange and Laplace. There's several law mathematicians but anyway, so you can do that. So sustainability in space, NASA has a whole branch of itself committed to this, and it's called ISRU, In Situ Resource Utilization. So if you fly to Mars and you don't have any rocket fuel left, well, we're pretty sure there's water under the surface that was once there, now in a kind of permafrost. If you can extract it and build a machine that can separate the hydrogen from the oxygen of the H2O molecule, well, now that you've separated them, if you bring them back together, it's highly exothermic. So that's rocket fuel. In fact, that is the fuel in the main engine of all the rockets today. Okay, they're supplemented by solid rocket boosters, of course, but the main engine is hydrogen and oxygen, separated in separate tanks, and they're nozzles that combine them. And therein is a source of energy. And you know what the exhaust is? Water. That's the exhaust. Okay, so that's one way to sort of have fuel available to you that you don't have to bring. And again, do you create a farm there, or do you need to build a habitat module so that you can keep an oxygen supply for animals if you have animals versus the plants, or the plants giving you the oxygen? So there's a lot of frontier thinking that still needs to be solved in this effort. So we're at our infancy there. I think it's good to always think in that way. And by the way, if let's say you get there and one of your machines breaks and you need a bolt, it physically breaks, you need a bolt, and you need a 3D printer that can print metallic objects that you just send it the CAD diagram, and boom, out comes a wing nut, a bolt, a hex wrench, but then you need the raw material, you need the aluminum, you need the iron, you need the alloys. So there's a lot of thinking to happen there, and I think it's great but we're not there yet. No. Totally not there yet.
And you mentioned these two scholars, Laplace and Lagrange, and I happened to work on a solar cell mission that was to Lagrange point 2, and it was very futuristic, as you say, exploratory in a sense that we would have a Gossamer structure, deployed in space, being rigidized due to the resins and basically bouncing off the photons of the sun to get propulsion to get to Lagrange point 2. So as part of what you describe, and I have to say, the Laplace transformations, I don't miss them. My engineering class, but
that's okay. But we can still love the Lagrange points. Okay,
for sure. And I think that's really what this journey that I personally have had is just goes again back to that discovery and exploration of their possibilities out there. Maybe even every technology that we're exploring right now for space sustainability is not going to ever get there in terms of technical readiness level, but nevertheless, it's worth exploring to see how far we can get.
Entirely. Right? And just to get our Laplace and Lagranges cleaned up. So we have the Lagrangian points and the Laplacian transformation, but there's also the Lagrangian representation of energy. Okay, you have a Lagrangian is the energy state of a system can be represented as in what we call a Lagrangian as well. So yeah, their names are all over the place.
Very interesting.
And by the way, when I was in high school, I had a friend of mine. I went to the Bronx High School of Science, and a friend of mine was named Frank Larice. And during our lunch breaks, because we just learned about the Lagrange equations, and he imagined one day there'd be a formula named the Larice equations. And I didn't have a law in my name, so I couldn't go the same place his brain was going. But it was fun to just imagine.
But you have an asteroid named after you, so that's...
Yes, I do. Yes. By the way, I checked with the people who awarded me the asteroid. I say, is it headed towards Earth? You don't want to be that guy.
You don't want to do the Tyson, dark mission on that one, right?
Ready to render the species extinct. You don't want to be that guy. So I was affirmed. It was affirmed for me that the asteroid is safe in the asteroid belt. Yes.
Wonderful. We've come really far in this conversation. So many fascinating topics. One of the ones that I definitely want to discuss with you is this increasing space activities and the orbital debris congestion. And of course, if this prolongs with increased activities, we might run into a problem getting even to space as we wish. It's not really a definition 1 centimeter out, right? But to get to low Earth orbit. How do you perceive our increasing space activities and the role of these satellite constellations out there to really, how do you perceive that trend, and what are your observations regarding what can happen next?
Well, there are two different issues. One of them is space debris, which can be hazardous, especially since some debris is not tracked because it's too small, but it's still going at very high speeds. What would it be, like 12 kilometers per second? All right, these are very high speeds. This debris could be rocket parts, paint chips, broken, anything that fell off of something that was in orbit. All right, can be considered debris because it doesn't belong there. The debris field is, if you look at NASA tracks this, and of course so does the military, but the NASA has a site where you can see the ones that we are tracking, and it's embarrassing. It's like, oh my gosh, we're sitting in the middle of our own dumpster, okay, our own dump truck. There it is. And I'm convinced aliens would have visited us by now if it weren't for the debris. They came up in their flying saucers and say, what? No, we're not going to risk coming down to visit them. Let's go back. And then they go back and they say, there's no sign of intelligent life on Earth. We used to have a saying as a kid, we're peeing in our own bathtub. Okay. This is and so that's a problem. And we don't really have a way to fix it, particularly debris that's so high up that it will never re-enter Earth's atmosphere. In middle Earth orbit and geosynchronous orbit, debris there is there forever, basically forever. Only the low Earth orbit debris has a chance of coming out of orbit because you have a few molecules of air that it hits, and that slows it down a bit. It drops to a lower orbit where there's even more molecules, and then it drops to even lower. And so it's exponential when that happens. And ideally, since you're not controlling this reentry, you want it to burn up before it hits Earth's surface. Larger pieces, if you can execute a controlled burn to slow them down, you can drop them into the Pacific Ocean. So the Pacific Ocean is the great toilet bowl of the space era. All right, that's so many things are just sitting at the bottom, at the bottom, because the Pacific Ocean is fully a third of all total longitudes on Earth.
Yes.
So you don't have to deorbit very precisely, and you still just end up in the Pacific, right? And the chances of hitting a barge or some other vessel are very small, and so people don't concern themselves with it. So, how about just the sheer number of satellites? Yeah, I would call it satellite pollution. As astronomers, we first encountered light pollution. All right, we had to move observatories far away from cities as cities became electrified. Then we had air pollution, smokestacks belching out dark smoke interfering with our view of the sky. Then we had electromagnetic pollution. What is that? Well, I have a radio telescope. Oh, but wait a minute. You have a cell phone that's also using radio wave communication, right? Very short radio waves, microwaves, but still. All right. And so now I'm trying to observe subtle, dim things in the universe in a band of light that you are using to communicate with your friends.
Yes.
All right. So that's electromagnetic pollution. Now we have satellite pollution. Oh my gosh. I'm trying to take a time lapse of some object in the night sky, and then a train of satellites marches through my images. That ain't right. What? No. Right now, there is an organization that is devoted itself to keeping the sky pure.
Yes.
Visibly pure in whatever way. Even if it's simple things like, can you paint your satellites dark? Like a matte black, so that they're not so reflective, because they don't give off their own light. They're reflecting sunlight back to you. And so there's discussions afoot. And the satellite companies are, I think, by and large, are being cooperative, at least in goal, if not in what they can introduce today. But yes, as part of their mission statement, I think they're being quite responsive. And so, but I don't know what the long-term future of that is. Maybe we can only do modern astrophysics from the moon or from orbiting satellites at high up. that are above whatever at the level of the other satellites that would otherwise dance across your pristine field of view.
Yes, and I think, as you correctly said, the orbital debris congestion situation is also very multifaceted, multidisciplinary. It's not just technologies, legislation, national security, and other things. And it's encouraging in some ways that they're actually looking into active debris removal techniques, and they're looking into maybe just having a shorter lifetime for satellites. And so it's, again, one of those problems that need to be solved. So it's something that we at least can address. I'm going to pivot here into some rapid fire terms. And what I mean with that is that I'm going to basically just mention a term and ask you to please share with us what pops into your mind.
So it's a verbal Rorschach test. Yes, that's what that
yes.
is. Yes.
All right. So let's start. Sun.
When I think of the sun, I think of beautiful sunsets and sunrises that bookend not only the day, of course, but for me, they bookend the night where I have access to the universe.
And the moon.
No astronomer likes the moon at all because it interferes with the rest of our viewings of the night sky. So I like the moon when you can't see it. And that would include total solar eclipses. You can see the backside, but it's not lit. It's the other side that's lit, and it makes for a beautiful image as it blots out the light of the sun. So for me, the moon is eclipses or not at all.
Mars.
We're long overdue for hanging out there, and so I think of that as a very important next destination in space.
Uranus.
For people. Mm-hmm.
Yes, for people, yes. Uranus.
Yeah, I don't have much thoughts about Uranus at all, other than my daughter is named for one of its moons. So that's what I think about that.
Jupiter.
Yeah, we say Jupiter, I just picture Jupiter with its very interesting bands, weather bands across its surface and its giant red spot. And I just think of it as a very active atmospheric planet. And however much we would complain or comment or observe the variation of atmospheric weather of our planet, driven by solar heating as well as our rotation and the Coriolis force, you realize Jupiter rotates twice as fast as Earth does.
Yes.
And it's 100 times bigger, right? In volume. So is it 100? Yeah, 10 across. No, 1,000 times bigger in volume. So whatever we have going on Earth, it's going to be way more happening on Jupiter. And so I love to think of the climatic extremes Jupiter is capable of.
Venus.
I don't think much about Venus. It's beautiful in the evening and morning sky. In fact, morning star and evening star. In German, there's a surname called Morgenstern, right? That's morning star. Generally, if someone refers to a star in the morning, they're actually talking about Venus because it never wanders too far from the sun, because it orbits closer to the sun than we do. So in the sky, you're going to find Venus nearby wherever you see the sun. If the sun is just set, and you're going to see Venus is going to be right there on the western horizon. And just before the sun rises, it'll be right there on the eastern horizon. So I just love the fact that we think of it as a star, even though it's just simply the brightest planet.
Yes. Saturn.
My favorite planet.
Why is that?
Well, how could it not be? Actually, it's my second favorite planet after Earth. Saturn with its beautiful ring system. Oh my gosh. If it's not one of the most beautiful things you've ever seen in the universe, I can't help you.
Very fascinating. Black holes.
Avoid them. That's all. That's my only.
You don't want to get sucked into.
It's a fun test of general relativity, and if I were to die, I'd want to die falling into a black hole. if my choice is hit by a bus or death by black hole, I'm picking black hole.
So, and this is probably the last one. It's not really a term. What's the most fascinating thing about the universe? And it's maybe very difficult to answer this question, but if there's something that stands out to you as really astonishing.
Okay, so I have two answers.
Okay.
My first answer is a cop-out answer. It's a cop-out because I was once asked that by Time magazine.
Okay.
And I answered it, and it went on YouTube, and it's on YouTube now, and it's got tens of millions of views.
Okay.
And they asked, what's the most astonishing fact about the universe? So I invite your viewers, listeners, to find that on YouTube, where I share with the viewer and the listener, for me, the most astonishing fact. Now, I have an additional astonishing fact. It's that the universe is knowable at all. By this little, 10 pounds of gray matter, however much our brain weighs. How much does our brain weigh? 5 pounds? Somewhere around there. And yeah, the fact that we can apply some of this neurosynaptic chemistry, like electrochemistry in our brain, and come to any understanding at all about anything in the universe at all. This intrigues me. I think that's an astonishing fact.
It surely is. So, Neil, we have almost reached the very end here. I just have one question for you regarding people who are either space interested or they're on the fence into get into the space arena of some kind. What are some of the recommendations you can make? And even those who are not necessarily want to be astrophysicists, but still want to explore the universe, and any piece of advice that you can share with them?
Sure. I would say that I don't think anyone is on the fence about whether they want to study space. Once you started climbing that fence, you're going to get over the fence and you're going to walk away from the fence towards space. No one is sitting there. Let me think about space. I've never met anyone on the fence about it.
Okay.
That's just an empirical statement. Second, let's say you like space, but you were never good at math, or you don't have the patience for the engineering. Plenty of places to go, things to do. For example, space law. That's a whole frontier. All right. If you find an alien on Mars and you kill it, is it murder? If the alien was not human, but the alien was smarter than you? These are legal questions that there's a huge frontier. If you're an artist of any stripe and we discover something new in the universe, take it to Hollywood, take it to a publisher, create a storyline that surrounds it. Other things, if you're a medical doctor, you like medicine in general, there's all kinds of unsolved medical frontiers that we have going in everybody's modern efforts to understand the universe. So there are a lot of ways to contribute.
Wonderful. Thank you so much for your time, Neil. It was a pleasure talking to you.
Excellent.
And
well,
again,
thanks for your interest.
Of course, and it's many more questions, but we hope to have you back here at Space Talk at some later point in time, and wish you the very best.
All right. Thank you.
Thank you, Neil.